In this video, we're going to look at a fourth and final technique for solving quadratic equations. The first technique we had looked at was factoring, and while factoring was pretty quick and easy, factoring doesn't always work because not every polynomial can be factored. The second technique we saw was the square root property, which again was pretty quick and efficient, but it doesn't always work. So in the last video, we saw a technique that worked all the time for every quadratic equation. That was completing the square. But what we did see at the end of the second video of completing the square, we saw that sometimes we had to work with fractions and it got pretty messy. So this last technique that we're going to look at is a technique using what we call the quadratic formula. It again, like the completing the square, is going to work for every quadratic equation, but the upside is that it doesn't get more difficult from one problem to the next. It's always going to be a simple plug and chug. So here's an example of a quadratic equation that we're going to solve using the quadratic formula. The quadratic formula here is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you're looking for a trick to help you memorize it, I'll tell you a story. A negative boy couldn't decide whether or not to go to a rad party. The boy ended up being a square, and he missed out on 4 awesome chicks, and the party was all over at 2 a.m. You are going to want to memorize this formula, so whatever it takes to help you memorize it, whether it's a song or whether it's a story, make sure you do it. And every time you do an example, I would encourage you to write that formula down. Again, that repetition will help you to memorize it. So what I'm going to do is I'm going to be plugging and chugging with this formula. I need to know a value for a, b, and c to plug in for those letters there. A, b, and c refer to the coefficients in front of each of these terms. When I don't see the coefficient in front of x squared, I know that it's 1. And so as I look at this trinomial, I see that a is 1, that coefficient in front of x squared. I see that b is 5, that's always the coefficient in front of x. And I see that c, the constant, is negative 6. My job now is to take those 3 values, plug them into the formula, and crank it out to find what x equals. So in my first step, when I substitute, what I'm going to do is I'm going to plug these in and put parentheses around them. Again, anytime you plug something in, putting parentheses around it will help you avoid mistakes. So where I see negative b, I'm going to have negative 5 in parentheses, plus or minus square root. B squared will be 5 squared minus 4 times a times c, so in this case that's times 1 times negative 6. All that stuff was under a square root, and now this is all over 2 times a, which in this case is 2 times 1. So my very first step after writing the formula is just plugging things in, showing that where there were b's, there are now 5s, where there were a's, there are now 1s, and where there was that c, there's now the negative 6. So it's just plugging stuff in. At this point, we want to start cranking things out. So what I will encourage you to do next is all of your multiplication. Negative times 5 is negative 5, plus or minus square root. Now when I see 5 squared, that's technically 5 times 5, so I'm going to get 25. And then I have negative 4 times 1 times negative 6. A negative times a negative will be positive. 4 times 1 is 4, that times 6 is 24. This is all over 2 times 1, which is 2. So first I write the formula, then I plug everything in place of the a's, b's, and c's, and now I've done all my multiplication. The next step is to clean up the radicand. So under that square root, I'm going to do the addition, 25 plus 24, to get 49. Once I've cleaned up the radicand, my next step is to clean up the root itself. In this case, the square root of 49 is going to be exactly 7. So I now have negative 5 plus or minus 7 all over 2. Now because the negative 5 and the 7 are like terms, they're both nice whole numbers, I can actually combine them. So I can read this fraction 2 different ways, one with the plus sign and one with the minus sign. So let's see what we get for our two answers when we do that. -5 plus 7 is 2. 2 over 2 would give me 1. Looking for a second solution, -5 minus 7 is -12. -12 divided by 2 is -6. And so I have two solutions, which I expect because I had a degree 2 equation. I have found that x is 1 or -6. As we go through this video, we're just going to try additional examples. Sometimes the square root's not perfect, sometimes we don't have like terms to combine, but in every other sense, these problems will be essentially the same. It's just plugging in different numbers and cranking it out to see what we get for x. So again, when we're using the quadratic formula, before we can plug things in, we need to know who a, b, and c are. So let's pay attention to what coefficients we have here. A, again, is always the coefficient on x squared. If you don't see it, it's a 1. B is the coefficient on x, which in this case is a 7. And c is the constant, which is 4 for this example. Now our job is to take these three values and plug them into those letters. And again, when you substitute or plug in, I would encourage you to use parentheses because sometimes it makes a difference. So when I see -b, I'm going to write negative, and then in parentheses I'll write that value for b, which is 7. Then I have plus or minus square root. b squared becomes 7 in parentheses squared. Minus 4. A times c. A is 1 and c is 4. Again, I'm putting those values in parentheses as I plug them in. Now all of that was under a square root, and all this stuff is over 2 times a, which in this case is 2 times 1. So first step is to write your formula, second step is to plug things in, and now what we're going to do is start cleaning this up, and the first step we'll take is to do all of the multiplication. So negative times 7 will be -7, plus or minus square root. 7 squared is really 7 times 7, that's going to give us 49. And then I have -4 times 1 times 4. -4 times 1 is -4, and that times 4 is -16. This is now all over 2 times 1, which is 2. So formula, plug it in, multiply. Now our job is to clean up that radicand. So we're going to do the subtraction that's under the root. So I have -7 plus or minus the square root, and then 49 minus 16 will be 33. This is still all over 2. Make sure that as you're going from one step to the next, you're not losing any of those details. You're keeping the entire picture. Now in this particular example, the next step would be to take the square root of 33, but I can't because it's not a nice square. In fact, there is no perfect square in 33, so this root will not clean up. More than that, I can't combine the nice, clean whole number 7 with the irrational square root of 33, so I can't do the addition or subtraction, and the GCF between all three terms is 1, so that's actually as far as I can get. Here are my two solutions, -7 plus the square root of 33 all over 2, and then -7 minus the square root of 33 all over 2. Again, I'm getting two solutions. So this actually showed fewer steps than the last example, simply because I could not take the square root of 33 and I couldn't actually combine anything to clean it up. So I got done a little bit faster than in the last example. Let's take a look at another. Again, to use the quadratic formula to solve a quadratic equation, we first need to identify a, b, and c. A is again the coefficient in front of x squared, so in this case a is 1. B is the coefficient on x, in this case b is -6, do be sure to watch your signs. And c is always the constant, in this case 9. So now we will replace a, b, and c in this formula with these values. Remember, as you substitute or plug in, to use parentheses when you do so. So -b will be -6 in parentheses, plus or minus square root. And here's where the parentheses are very important. Instead of b squared, I'm going to have parentheses -6 squared, minus 4, and then times a times c, so times 1 times 9. And this is all over 2 2 times a, which means 2 times 1 here. So I haven't done any math yet. All I've done is I've copied the formula and I've replaced the a's, b's, and c's with the values they represent. Now comes the math. Now I want to take care of all the multiplication I need to do. So negative times negative 6 is just positive 6. Plus or minus square root. Negative 6 squared means I'm taking negative 6 times negative 6. That's going to give me a positive 36. And then negative 4 times 1 is negative 4. That times 9 is negative 36. This is all over 2 times 1, which is 2. So again, we're trying to clean this up, trying to figure out what x equals. We've done the formula, the plugging in, all the multiplication. Now let's clean up this radicand. And when I actually do that subtraction, 36 minus 36, I get 0. And because 0 is technically a perfect square, let's go ahead and take that square root. The square root of 0 is just 0. And so I've got 6 plus or minus 0 all over 2. Now remember that plus or minus is telling me there are two different answers. Let's take a look at what those answers are here. Because 6 and 0 are like terms, I can think about combining them. 6 plus 0 is 6. 6 over 2 is 3. If I do the subtraction version, 6 minus 0 is still 6, and 6 over 2 is again 3. So technically what's happening is I'm getting 3 as a solution twice. I got it once when I added 0, and once when I subtracted 0. Now when it comes to writing our solutions, we will write x equals 3 because we don't want to be redundant by saying x is 3 or x is 3. That would be silly. So we're just going to write the x equals 3 once for our solution, but I'll tell you that because the 3 technically happened twice, this solution has a special name. We call it a double root. And for this class right now, the fact that that's a double root, the fact that the 3 happened twice, it doesn't really mean anything to us now. But when we get to college algebra, that's going to mean something to us. When we're graphing polynomials, if an x-intercept happens twice, and it's the same value happening twice, what will happen is instead of a graph slicing through the x-axis, it'll bounce off of that x-axis because the root happened twice. So it doesn't necessarily mean anything to us right now, but we'll see that in college algebra. The only reason I emphasize this to you here is I want to make sure that you see this isn't a contradiction. Even though I say x is 3, I expected 2 solutions. Well, 3 happened twice. So there's no contradiction to the rule that the highest exponent tells me how many solutions. In this case, it was 2 solutions, but they weren't 2 different solutions. It was the same solution that happened twice. So this is an interesting example. Let's try one with maybe some complex answers. Again, we begin by identifying who A, B, and C are. In this case, A is the coefficient on x squared, which is 4. B is always the coefficient on x, and if you don't see one, remember it's a 1. So the coefficient on x here is -1, and C is always the constant, which in this case is 4. And our job is to take those values for A, B, and C and plug them in for their letters. So here, -b will be negative, and then parentheses -1, plus or minus square root. B squared will be parentheses -1 squared, minus 4, and then times A times C. So in this case, times 4 times 4. Again, every time you're plugging something in, put parentheses around it. And then this is all over 2 times A, which means here 2 times 4. So we write down the formula, we plug everything in, and now comes the math. Now we're going to start by multiplying what we need to multiply. So upstairs, negative times -1 is just 1, plus or minus square root. -1 squared means -1 times -1, which is just +1. And then I have -4 times 4 times 4. So -4 times 4 is -16. -16 times 4 is -64. This is all over 2 times 4, which is 8. So I write the formula, I plug things in, I multiply. Now let's clean up that radicand. Underneath the root, I'll have 1 minus 64, which is negative 63. Again, this is all over 8. Now at this point, my job is to clean up the root. The square root of negative 63 is not going to be perfect, but there is something perfect inside. So what I'd recommend you do is maybe go off to the side to play with that root. We have square root of negative 63. Let's play with this and see how it cleans up. First thing I'll do is I'll take care of that negative. If there's a negative under a square root, I know that this is imaginary. So I have I times the square root of 63. And now in 63, I'm looking for a perfect square. And so hopefully 63, when you look at it, rings a bell from your memorized multiplication table. 63 is going to be 9, which is a perfect square, times 7, which is going to be our nasty irrational leftover. So I times the square root of 9 is I times 3. That's just 3I, and then I have the square root of 7. So here's how my root will clean up. So I will have x equals 1 plus or minus, instead of square root of negative 63, I have 3I square root of 7, and this is all over 8. So I have cleaned up the root, and now the last step would be to clean up the fraction if I can. If I can combine terms upstairs, I will, but I can't because here I have a real number and an imaginary. They won't combine. And if I can simplify the fraction, I want to. But in this case, between all three terms, they share no GCF other than 1, which everything shares. So there's no way to simplify this any further. This is going to be my final answer. Notice that it again shows two solutions. One says 1 plus 3i square root of 7 all over 8. The other says 1 minus 3i square root of 7 all over 8. So that plus or minus is always helping us to see two solutions, which should happen in these degree 2 quadratic equations. Now, so far the examples we've seen, the quadratic equation was set up so that there were no parentheses trapping anything. It was in descending order and it already equaled 0. So it's kind of set up the same way we would want it set up when we're factoring. But we know that not all equations are presented to us in that way. So let's take a look at just a couple equations that are set up not quite in our favor. We need to adjust those a little bit before we can start plugging and chugging. So in this example, we see that we can't directly start identifying A, B, or C because this equation's not yet in the correct format. Before I can identify A, B, and C and start plugging things into that quadratic formula, I need no parentheses and everything has to be shoved to one side and in descending order. So let's take this equation off to the side here. We had x times 6x plus 2 equals 3. And let's just play with that equation a bit to get it in the right format. First things first, I need to get rid of the parentheses because they're trapping some of these terms. So let's distribute to remove parentheses. That's going to leave me with 6x squared. X times 6x is 6x squared. X times 2 is 2x. And on the right side, I still have that 3. So the parentheses are gone, but I need this set equal to 0 before I'm allowed to start plugging things in. So let's relocate this 3, and since he's currently positive, I'll relocate him using subtraction. So on the left side, I have 6x squared plus the 2x minus 3 now equal to 0. And now this looks much more like the examples we started with before. This is where we want to begin as we plug things in. So as I look at this, I'm just going to identify here who my A, B, and C are. A is 6. B, the coefficient on x, is 2. And C, my constant, is negative 3. So now that I've pulled all that information and I found who A, B, and C are, now I can start plugging and chugging. So I know I'm going to need more space here. I'm going to erase this out of here. I have the information I do need to plug things in. So again, put parentheses where you plug things in. So when I see negative B, I want negative parentheses 2 instead of B. Plus or minus square root. B squared becomes parentheses 2 squared. minus 4, and then times a times c will be times 6 times negative 3, again using parentheses every time I plug something in. Now this is all over 2 times a, which in this case is 2 times 6. So I've got the formula, I've plugged in who a, b, and c are. Now I go to my multiplying. This is where the math starts. So x equals negative times 2 is negative 2, plus or minus square root. 2 squared is 2 times 2, which is 4. Negative 4 times 6 is negative 24. Negative 24 times negative 3 is positive 72. And this is all over 2 times 6, which is 12. So again, formula, plug things in, take care of the multiplication. Now our job is to clean up this radicand. So I have negative 2 plus or minus the square root. 4 plus 72 will give me 76. And this is all over 12. So now the next step would be to clean up that square root of 76. Now the square root of 76 is not perfect, however, there is a perfect square inside it. So let's go off to the side and see if we can clean up the square root of 76. And if it's a number that's larger, you might not necessarily know right off the bat what to use, but I know at least a 4 goes into this. So I'm going to break this down into 4, which is a perfect square, times the leftover, which in this case, if I take 76 divided by 4, I'm going to get 19. Now 19 has no perfect square in it, so I know that this was the right split. So square root of 4 is perfect. It's going to give me 2. Square root of 19 is the yucky leftover. So when I'm cleaning up square root of 76, it cleans up this way. Let's go ahead and write that over here. So we now have x equals negative 2 plus or minus. Now instead of square root of 76, we have 2 square root of 19. And this is all over 12. So again, I've got the formula. I plug things in. I multiply. I clean up the radicand. I simplify the root. And now my job is to either combine the like terms here if possible, and or simplify the fraction if possible. Now upstairs, I can't combine the negative 2 with the 2 square root of 19 because one has a root and one doesn't, so they stay separate. However, when I look at every term in that fraction, I notice that they all share a GCF in common. Every single one of these terms has a 2 for a factor. So I can divide by 2. 2 goes into itself once. Again, 2 goes into itself once. 2 goes into 12 6 times. This is going to help me reduce my fraction. So I now have x equals negative 1 plus or minus 1 square root of 19. I can just write square root of 19 for that, all over 6. And now each term has nothing but a 1 as a GCF, and so this is my final answer. So this one took a little bit of extra work because not only could we clean up the root, but the fraction itself was able to be reduced because every single term had a common factor we could divide out. So this is a good example to use to practice the quadratic formula. Let's give one more example a try. So again, where you really need to be careful when using the quadratic formula is ensuring that before you start plugging things in, your equation's in the right format to begin with. So I need to make sure there are no parentheses, and I also need to make sure that every term has been shoved to one side so it's set equal to 0. It also needs to be in descending order. So let's take a look at this example here. I don't have any parentheses to worry about, which is great. However, this is not an equation set to 0. So be very careful. Don't assume that A is 3, B is 6, and C is negative 5. This is not in the right format yet. So let's take that equation off to the side here. 3x squared equals 6x minus 5. Our job is to now set it equal to 0 to get it in that correct format. So if I'm going to set it to 0, each of the terms on the right side need to move to the other side. So I'm going to take this positive 6x and I'm going to subtract it from both sides. That leaves me with, on the left, 3x squared minus 6x equaling negative 5. I need to do the same thing with the negative 5. I need to relocate it to the other side. So since it's a negative, I'm going to add 5 to both sides. That will set this equation to 0. Let's make sure that when we do so, we keep this in descending order. So 3x squared comes first, negative 6x comes second, the constant 5 comes last, and this is now set equal to 0. So now that this has no parentheses, it's set to 0, and the non-zero side is in descending order, we've got the right format. From here, we can see who A, B, and C are. So again, A is always the coefficient on x squared. In this case, that's a 3. B is always the coefficient on x. Be careful of the signs. In this case, it's a negative 6. And C is always the constant, which in this case is 5. So notice that these numbers are not the same as what you would have gotten if you just took it as it was written originally. So watch the order and watch that it's in the right format with no parentheses, and it's got to be set equal to 0. Once you've got that, you've identified who A, B, and C are, we can just go ahead and do our plugging and chugging. Again, don't forget that when you plug something in, you put stuff in parentheses. So negative B will give me negative, and then negative 6 in parentheses instead of B. Plus or minus square root. Instead of B squared, I'll have parentheses negative 6 squared. Minus 4 times A times C, in this case is times 3 times 5, where all of this is under a square root. And this whole thing is a fraction over 2 times A, which in this case is 3. So again, as you're going through these examples, every single time you do an example, write that formula again, and then show a step where all you're doing is plugging in who A, B, and C are. We're not actually doing math here, it's just substitution or replacement. Once we've done that, now we can start the math. We are going to do the multiplications first. So negative times negative 6 will give me a positive 6, plus or minus square root. Negative 6 squared is negative 6 times negative 6, which is positive 36. And then I have minus 4 times 3, which is negative 12, and negative 12 times 5 is negative 60. This is all over 2 times 3, which is 6. So we write the formula, we plug things in, we take care of all multiplication, and now we want to clean up the radicand. Let's do that subtraction. We now have 6 plus or minus the square root. 36 minus 60 is going to give us negative 24. And this is all over 6. So once we've condensed it down, we see just one number in front, one number under the root, and one number on bottom. Now is the time to clean up the root if possible. So in this case, let's take this off to the side. Let's look at that square root of negative 24. The first thing I notice is there's a negative under the square root, which means this is imaginary. So I'm going to take that negative out, and it will look like the letter I. And then I'm going to look at that square root of 24, and I'm going to try and break it into a perfect square and a leftover. The perfect square that goes into 24 is going to be 4, where the leftover is going to be 6. So I've got I times the square root of 4, which is I times 2, or 2I. And then I have square root of 6 left over. So where I saw this square root of negative 24, I can replace that with this 2I square root of 6. So let's write it over here. X equals 6 plus or minus, instead of this root, I'll write its simplified form, 2I square root of 6. And this is all over 6. Now that I've cleaned up the root, my last job is to either combine like terms if possible, or just in general, take care of the fraction. Is the fraction able to be simplified? Now be careful as you're simplifying the fraction to capture common factors in the correct locations. Just because I see the symbol 6 in all three locations here doesn't mean that it's 6 that's reducing. Keep in mind that it has to be like factors that you are canceling or dividing out. This 6 is under a root, and that's different than a plain 6 not in a root. Where I want to look is the coefficient where I have my non-root pieces. So with my terms, in looking at the non-root parts, I have 6, I have 2, and I have 6. Their greatest common factor is 2. I can divide 2 from everybody. So 2 goes into 6 3 times. 2 goes into itself once. And again, down here, 2 goes into 6 3 times. And so the way this fraction cleans up, I will wind up with x equals 3 plus or minus 1I square root of 6, I'll just say I square root of 6, all over 3. Again, be very careful not to try and divide terms. We don't want to touch the terms, so don't touch these 3's. Every single part would have to have the same factor in common, and just because the 6 has a 3 that goes in it, be careful, this 6 is under a root, so he's a different type of factor than the 3 you see down here. Here's my simplified fraction. And again, we're seeing with all of these, the plus or minus symbol is helping us see the two solutions that we expect for the degree 2 quadratic equations. In this case, the two solutions would be 3 plus I square root of 6 over 3. The second solution would be 3 minus I square root of 6 all over 3. So now we've seen 4 different techniques of solving quadratic equations. Some of them are very fast, some of them can get a little bit messy and take forever to get through. What I will tell you is that when it comes to the exam, I am going to have at least one question on the test that requires each of the different techniques. So factoring is something I want to see. And the square root property is something I'm going to want to see, as well as completing the square, as well as the quadratic formula. So don't just pick a technique you like and only practice that one. So just because you might like the quadratic formula, don't forget all the other ones. Because completing the square is going to be important as a technique when you get to college algebra, when you start working with conic equations. So I would just encourage you to practice all the different techniques as the directions ask you to. In the next video, we'll look at what to do if the directions don't dictate how to solve it. If they don't say solve by completing the square or solve using the quadratic formula, we'll talk about how to make the decision of what's the most efficient, wise choice for solving that quadratic.